Hey, welcome, Math 2 class. This is section 6.3, Polynomials, understanding what a polynomial is. So I will go over these answers as quickly as possible, so pay attention. Here we go. It says for each polynomial, find the variable terms and their coefficients, any constant terms, and the degree of a polynomial. If all the terms of a polynomial have a common factor greater than 1, find the greatest common factor of those terms. So let's find the degree first. I'll use capital D for degree. I'll write it out this time. So there's my degree. And my degree, based on what I see here, is x to the negative 4x to the third power is the largest exponent there. So my degree is 3. Okay? This isn't written in standard form. The variables, the variable terms are there are 6x and negative 4x to the third. And then, of course, we have something called the coefficients. And so the coefficients, I'm just going to highlight. Okay, guys, the coefficients are 6 and negative 4. Then it says identify the constant. Okay, the constant would be number 14. Alrighty. Now it says if all the terms of the polynomial have a common factor greater than 1, find the greatest common factor of these terms. So looking at 6, 4, and 14, 2 would be the greatest common factor. So the GCF, greatest common factor, would be 2. Alright, let's continue. The degree here is 4 again. Variable terms. Again, the coefficients of the variables are highlighted in yellow. Keep track of those signs too, by the way. Your subtraction symbols represent negative numbers. Okay. And finally, the constant here, there is no constant. So what is the GCF? Let's see. We've got 12, 24, 18, and 30. So I'm thinking 6. 6 goes into 12, 24, 18, and 30. So my GCF is 6. But also, pay attention. Look at my variables, t to the third, t squared, and t to the fourth power. So t is common in each. So my greatest common factor is 16. So I'll stop there. We'll see if I can, well, maybe I'll do one more. Let me just slide down here. 1 second here. Okay, let's go there. Why not? All right, so again, this idea here, what I want to do is I want to identify the degree of this polynomial, since I haven't done so. So the degree of the polynomial here, you're going to notice a couple of things. So you have x to the third power, and then you have x squared and y1. See that? Y to the first power. This is x and y squared. And so each of these terms, this has a degree of 3, since you add the exponents in the term. If there's 2 or more variables with exponents, you add them. And so there's 3, 3. So it looks like every single term has a degree of 3. 3, 3, 3, 3. So the degree is 3. Okay. Then, of course, you know how to identify the coefficients. And then it doesn't look like there is a greatest common factor for each of these. So, yeah. Now, next question. It says, write each polynomial in standard form. identify the degree and leading coefficient of the polynomial. So let's write these in standard form. The greatest power is 6. So here we go. Standard form. So cross those off. 16z is a positive number, so I'm adding. Minus 1, of course, is still minus 1. And the degree is 3. I'll highlight that for you. The degree is 6, right? And the leading coefficient, I'll highlight that in purple, is 2. Okay? Degree is 6, leading coefficient is 2. It's in the lead, it's the first coefficient when the polynomial is written in standard form. Again here, same idea, 8 would be the first term. You get the idea. Now, for the sake of time, I'm going to keep moving on. Okay, so this question talks about a rocket being launched, and I think we did have a discussion about it. So I want to quickly discuss what's going on here. We're talking about a rocket, and it's modeled by this quadratic. Okay, and we know that it's on a platform 1.4 meters above the ground with an initial velocity of 107 meters per second. The height of the rocket in meters with time measured in seconds after the rocket is launched is modeled by this equation. So interpret and determine the polynomial. This is new stuff, this is physics. But what I see is this first term, what we talked about was this first term represents the force of gravity moving downward. And so it is the acceleration of gravity, okay? And so this term represents the acceleration of gravity measured in meters per second squared. Now, I know that sounds confusing, but that's what that represents. So we'll say negative 4.9 t squared represents the acceleration of gravity, okay? Okay. The 107 times t represents the velocity of the rocket, and it's the upward velocity. Again, gravity is a downward direction. This velocity here is upward direction. So this is the, again, is the acceleration of the rocket. Okay, so we'll write that down, and it's the it's the velocity upward. So I'm trouble spelling here. And then the last number is the position of the rocket on the launch pad, right? So it was launched on a pad that was 1.4 meters off the ground, okay? I'm having trouble writing with this writing pad, guys. It's new. Sorry about my penmanship. Alrighty. And so the next question says here, it says, use unit analysis to show how the value of the polynomial is a distance in meters. So this is tricky, so I'm going to write this down. I'm going to use a couple of steps here. So using unit analysis, Okay, so here's what we know about the situation here. The velocity is measured in meters per second squared. So technically speaking, when I look at this number, it is 4.9 meters over second squared, and that's again something you'll learn in physics. Now, we want our answer to be in meters, so in order for that to be true, let's see where it says t squared, the time. Here, I probably have to multiply by time in seconds, and that also is squared, since it's squared here. And so those units will cancel each other, and you're left with m, which is good. Plus, now again, 107 is the velocity, and that's meters per second. It's like miles per hour. In this case, it's meters per second, and that would be 107. If you're having trouble writing here, 107, and it would be meters per second, and so the time here would have to be in seconds, and it would cross cancel there, so that you get just meters. And finally, the height of the rocket on the platform is 1.4 meters. That's fine. And so by reducing, you can see that the seconds squared cancel, the seconds here cancel, and when you do all the work, you're left with an answer that has a unit measurement of meters. See that? And so, yeah, that's good stuff. And the actual answer could be, calculated if you had the seconds given, but yeah, we're not there yet. So anyway, with that said, let's try one more. See what we got here. Okay, these questions, we've got to know how to do these almost blindfolded, guys. These are standard questions that have to be solved quickly and efficiently. So it says find the degree, right? And the number of terms of the polynomial. That should be given. The degree here, 3. Degree here is 2. The degree here is 4. The number of terms, count them out. There's 3 here. For number 2, there's 2. For number 3, there's 1, 2, 3, 4. 4 terms, right? Here, write these in standard form. We've talked about that. I'll do one example, okay? One example. This is, for this one here, would be positive 4, 8x, right? That's gone. Plus 3x squared minus x minus 2. Remember, there is a power of 1 when you have a variable. And remember, too, that negative 2, there's a hidden ghost variable called x to the 0 power, which is 1, and when you multiply 1 times 2, you still get 2. So, yeah, we don't ever write the ghost variable, right? So, and we also don't write the 1 for the given variable. The leading coefficient is 4. Okay? So, scrolling down. Now, here it says classify each polynomial by its degree and a number of terms. And so, again, we have the discussion here about the names of certain binomials, trinomials, and things like that. We haven't had a formal discussion per se, but you've had Algebra 1, and I hope that some of those terms are fresh in your memory. If they're not, here we go. I'm going to classify them really quick. This would be, if I was to classify this polynomial, again, how do you classify a polynomial? Well, first of all, you want to look at your power, right? And so look at the power, and since it has a degree of 2, right, that's the highest power of 2, we call that a quadratic. So it has a degree of 2, we call that a quadratic, okay? And checking my spelling here, gosh, it's horrible. It has 2 terms, so that's called a binomial. So if you were going to name this, it would be a quadratic binomial. Here, it's got a degree of 4, and that's called a quartic. I know it's a fancy name, quartic, and it has 3 terms, so it's a trinomial. And then finally, I lost connection here, sorry guys. Power went out too. Uh-oh. That's strange. The trinomial. And this is also a quartic, but the problem here is that what do you call a polynomial with 1, 2, 3, 4 terms? A quadrinomial? No. You just call it a polynomial. So anything after 3, just call it a polynomial, which means many parts. And here we have some evaluation here. You want to evaluate these terms. And so how do we do that? Again, you evaluate these by substitution. So you want to take that value, plug it in, and come up with an answer. Okay, so if I was to do that, we'd end up with 3 times negative 1 plus 8 minus 2 times negative 1 to the 3rd power. Now, 3 times negative 1 is negative 3 plus 8 minus 2 times negative 1. Again, if you have to expand this, negative 1 times negative 1 is a positive 1. If negative 1 is a negative 1, then do that. So we have a negative 2 times a negative 1 is positive 2. This becomes negative 3 plus 8 plus 2. Adding from left to right, with 5 plus 2 is 7. Okay? So again, I'm out of room, but that's how you would do those. Okay? Now, I have not done all of the work per se, but again, I'm expecting you to do most of this too on your own, and we'll do some of these word problems in class. So I will see you tomorrow. Take care. Study hard and learn a lot.